In this video, we are going to use L'Hopital's rule to take a limit. Right. So here we have the limit as x goes to infinity of this rational function, 4x cubed plus x squared plus 1 over 3x cubed minus 5. And just recall that this is one of the types of limits that we talked about in Unit 1 on limits. And we had a different technique for computing this limit. But now we're going to do it differently with L'Hopital's rule. So what we have is the limit as x goes to infinity of a polynomial over another polynomial, right? We know that the limit as x goes to infinity or minus infinity of a polynomial is infinity or minus infinity. Here we don't really need to determine which one it is to know that we can use L'Hopital's rule. So even though these are both correct on these, right, you don't really have to figure out exactly which one it is. We are in the infinity over infinity situation, but it can be plus or minus infinity over plus or minus infinity, any combination of those, and you can use L'Hopital's rule. All right, so what we are going to do is, using L'Hopital's rule, take the derivative of the top function, which is 12x squared plus 2x, and put that over the derivative of the bottom function, which is 9x squared. And we're going to take a look at that limit and see what we get. Well, this limit is, again, the limit as x goes to infinity of a polynomial over a polynomial, right? So it is also, by the same reasoning as we had before, going to go to infinity over infinity. So we can use L'Hopital's rule again. All right, and L'Hopital's rule says, so I'll take a look at the limit of the derivative of the top over the derivative of the bottom. The derivative of the top is 24x plus 2. The derivative of the bottom is 18x. And again, by the very same reasoning, what we get is that we have a polynomial over a polynomial. So this is also an infinity over infinity indeterminate form. And we can use L'Hopital's rule again. When we use L'Hopital's rule again, right, we get the derivative of the top is 24. The derivative of the bottom is 18. And so if you simplify that out, right, you get 4/3. So we will have the limit as x goes to infinity of 4/3, and the limit of a constant function is just whatever the constant is. So this limit comes out to be 4/3, right? And we can follow sort of the chain all the way back using L'Hopital's rule, all the way back to the original, right? And L'Hopital's rule says that the limit as x goes to infinity of the original function, right, is also equal to 4/3 here. Okay, so that's how you can use L'Hopital's rule to compute limits of rational functions.